Hi, my name is Samuel and welcome to this hands-on workshop. In this workshop, we'll be implementing a machine learning technique to identify breast cancer. This simple web app will serve as a blueprint of how data scientists build models and move them into production. We'll be using Teachable Machine, a web-based tool that makes creating machine learning models fast, easy, and accessible to everyone. We'll be using Streamlit, a Python library that makes it easy to create and share beautiful custom web apps for machine learning and data science. Finally, we'll deploy the model on Heroku so that you can share your projects with friends. I can't wait to see what you build after this project. So, let's get into it. To get your environment ready, install the relevant packages by running this command on your command line. Pip is automatically installed when you install Python on your computer. In case you come across the pip is not recognized as an internal or external command error, make sure you add Python to your environment variables. With the 4 packages, you are ready to start a simple image classifier. Teachable Machine allows you to train classifier models on the web. You can create an image, audio, or post projects. In this case, choose an image classification project. For this workshop, you will use a breast ultrasound images dataset on Kaggle. I have done some image processing on the dataset. Follow the link on the resources file to download the dataset. Once on the image classification page, label class 1 as normal, class 2 as malignant, and class 3 as benign. Upload the images to the appropriate class. After uploading the data, click the Train Model button and wait for results. Now, let's make some predictions on the model using our test dataset. Okay, you got them right. Pretty cool, right? Once done, you will be able to download the weight file with a .h5 extension. This is what you use for your classification task. In your developer folder, create a file named app.py. This is the file that holds the Streamlit code responsible for displaying content on the web page. The following code sets up the page by giving it a header, title, and description. To ensure neat code and follow best practice, create a separate file named imageclassification.py to handle the actual classification. The following code will handle the file upload, processing by the classifier from Teachable Machine, and finally displaying results. To perform classification, load the weight file that you downloaded in the .h5 format into a Keras model. The next lines of code create the array of the right shape to feed into the Keras model. Since computers only understand numbers, the following code will turn the image into a NumPy array. Now, load the image into the array and run inference. Just below the import in the app.py, Add this line to allow you to use your classification function. The below code will be added to your app.py file. This is a conditional statement that checks the labels of the predator class against normal, malignant, and benign. To run your application on localhost, open up your terminal or shell, navigate to the current working directory, and run the command. The app will run locally and be available via the URL. At this point, your app is set up and running locally. It's time to share it. Register for a Heroku account to allow you to deploy your awesome classifier to the web. After registration, download the Heroku CLI or command line interface. Generate a requirement.txt file that will hold the libraries used and their versions. The file should look something like this. Create a setup.sh file and a proc file. These files will instruct Heroku on what to do to set up the app and get it running. In the setup.sh file, write the code below, which will create a Streamlit folder with a credentials.toml and a config.toml file. Next, the proc file will be the one that executes the setup.sh. Then, run the Streamlit app.py file proc file code. Initiate an empty Git repository using the command git init. In your terminal, navigate to the code's working directory and log into Heroku using the CLI command Heroku login. To deploy, run the command Heroku create. Upon completion of this command, Heroku will assign an app name and URL to your app, which will allow you to access it via the web. Last, push your code to your Heroku instance using the git commands below. To check if deployment was successful, run the command Heroku ps scale :web = 1. You have now learned to deploy machine learning solutions on the web using Streamlit to build the interface and Heroku to serve the app on the web. These skills are vital for real-world roles such as ML engineer, ML DevOps, software engineer with an interest in ML, and freelance ML enthusiasts who like to share their work. Thanks for watching.